In this video, I'm going to go through each of the problems on the Chapter 6 review. In the description and in Google Classroom, I'll post the times that each section starts. That way, if you need to jump around, you can do that. All right, so 1 through 4 all use this figure on the right, but they're all independent of each other. All right, so let's start with number 1. It says the measure of angle AXO. AXO is 32, so this angle here is 32. I want to know what's AXB. I want to know this whole angle right here. So if you remember, this is a kite, right? So we have congruent parts. Then that divides it into 2 smaller congruent triangles. So each of the vertex angles is bisected by that diagonal. So each of those little angles is 32. So together, that's a total of 64. All right, I'm going to erase that information there. Okay, it's still a kite, but now I'm going to do the next one. So number 2, if AOX is 48, then what's the measure of AXB? So again, I want to know this whole big angle. Okay, now I know that this is a right angle, right? Because the radius and the tangent formed a right angle. So I can solve for the missing angle of this triangle and I get 42. So again, that diagonal bisects my angle. So they're each 42, which gives me a total of 84. Okay, so I'm going to erase that. Okay, so now for the next one, it says the measure of angle AXB. AXB, so this big angle is 38. I want to know angle AOB. So this is one of those where you could either look at individual triangles, or if you remember, those 2 angles should be supplementary. So 180 minus 38 gives me 142. Then the last one here, it says if XB is 15, then what's the measure of AX? Well, it must also be 15 because the tangent segments are congruent. Next one says ABCD is a circumscribed quadrilateral with AD equal to 6. So this whole distance here is 6. Complete each statement. So I remember that these are all tangent segments, so they each have to be congruent, right? Okay, so I can follow that around. If this is 4, I know that y has to be 4. So I'm going to go ahead and mark all of those for us. That's 4. Down here at angle C, we'd have 2 and 2. At angle D, well, I can't get that yet, but if I go up to angle A, I have one segment is 3, so this has to be 3. If that whole side is 6, then this part down here at angle D is 3, and Z then is 3. So let's answer our questions. We know X, number 5, X is equal to 2. Y is equal to 4. Z is equal to 3. And then the entire length of CD is equal to 5. Okay, number 9 is a bit of a guess and check, but it's kind of hard to be wrong on this as long as you follow the rules. So ABCD is a circumscribed polygon. If AB is equal to 12, so that whole side length is 12, BC is 15, and CD is 25, I want to know what is the length of AD. Okay, now, keep in mind here, we have congruent segments, right? If I keep those congruent segments, I can almost choose anything, and I'll end up with the correct answer. So let's look at 12. Let's say I broke it down into, I can just do 10 and 2 even. So 10 and 2. I'm just going to make up 2 numbers that add up to 12, 10 and 2. So if I follow that around, I know the other segment here at B is going to be 2. BC, the whole thing is 15. So then this segment is 13, which means this is 13. If all of DC is 25, then my missing part is 12. Carry that around. And then I can also carry around up at A that side length of 10. So my total side length for AD is 22. All right, so I'm going to prove it to you. We're going to do a different way. So I'm going to erase what I have here, keeping in mind that we still have my congruent parts, right? So I'm going to erase what I know, or what I made it to be. Okay, so this time I'm going to break it up differently. So 12, I can make erase part of my markings there, sorry. So 12, I can do 5 and 7. Okay, so I know this part has to be 5. Oops, I erased too much. BC was 15, CD is 25. Okay, so now BC, the whole thing is 15. This part has to be 10. Carry it around, that has to be 10. DC has to be 25. So if I know 10, this has to be 15, 15, and this is 7. So again, I have a total of 22. Okay, now, if you start with your smallest side, it always works. Where you get yourself into trouble would be if, let's say I start at my 25. Let me erase my red here. So let's say I start on my side length of 25 and I call, I'm going to call this segment 20 and this segment 5. Okay, well, if I wrap around, this then has to be 20, but that whole side length is only 15, so it doesn't make sense that this would be -5. So if you start with the small side, you won't run into that. But if that happens, I can just make a different guess. You know, make this 15 and make this 10 and see if that gets you anywhere. Because then this would be 10 and then this would be 5. And then you can wrap yourself around and do it all again. Okay, but either way, you still end up getting 22 every time. So number 10, we need to find each of those following parts. All right, so looking at the figure, I see I have a perpendicular here, right here. I have a perpendicular, which means it's going to bisect that chord. So remember, if we have a radius that's perpendicular to a chord, it also bisects the chord. All right, so that means that these two parts have to be congruent. So I know y is going to be equal to 7. Now, this arc AC is also split by that radius. So if arc AB is 32, x is also going to be 32. So let's see, I think we've answered some questions. So y is 7, x is 32, arc AD. Okay, so we can see that this here is a semicircle, right? So if I take 180, subtract what I know, I'm left with 148. So that's 148. The next one is arc ABD. Okay, arc ABD. So A to B to D. So we're talking A to B to D. So we're going the long way around here. So I really need a semicircle there, 180, right? I need this semicircle, plus I'm going to need 32 more. So I have 180 plus 32. So I get 212. All right, so write the equation of a circle whose center is at 9, -3, and whose radius is 5. All right, so we got to remember we have a formula for the equation of a circle. So it's the quantity of x minus h squared plus the quantity of y minus k squared equals my radius squared. If you remember, we are replacing h and k, that's my center, and we're replacing r as the radius. So for this one, I'd have the quantity of x, I want the opposite of h. So instead of positive 9, it's going to become -9 squared, plus y, I want the opposite of k. So instead of a -3, it's going to be a +3 squared, equals my radius squared. So 5 squared gives me 25. Okay, I will be checking to make sure you have your squared, your plus, all of that. So make sure your format is correct. The next one, we just want to identify the center and we want to identify the radius. So remember, my center comes from my h and k here, my radius from my constant. So we have, remember, it's always the opposite of h and the opposite of k. So my center is at -7, +4. My radius is the square root of 225 or 15. So this one here, radius squared was 225. So therefore, the radius is 15. Okay, so here's where we're going to complete the square twice. So if you remember, our first step is to rearrange. So we have our x's together, leave a space, and then put our y's together and leave a space. And I'm going to get my constant to the other side, so it becomes -1. Okay, so I'm going to complete the squares for my x's. So -2 divided by 2 gives me a -1, and -1 squared is a +1. So add 1 to both sides. If I want to factor that, it's going to become x minus 1. So that was b divided by 2 and then we had to square it, right? That was our process. All right, so now let's do our y's. Okay, so I have negative 12. So negative 12 divided by 2 gives me negative 6. Negative 6 squared gives me 36. So I need to add 36 to both sides. So my parentheses is going to have a y minus 6 because that's the number I squared, right? Equals, now on the right hand side I have 36. So now I can read my center. That lies at positive 1, positive 6, and my radius is the square root of 36, or 6. For the next one, it says, penta is a regular pentagon inscribed in a circle. Find the measure of arc PA. All right, so if this is a regular pentagon, that means all 5 sides are congruent. So that means all 5 arcs are congruent as well. So I really just need to take 360 and divide that by 5. So that is 72 degrees. So every arc is 72 degrees. Okay, on this next one, we want to find the measure of angle P. I can see, again, I have congruent chords, right? I have congruent chords here, which means I have to have congruent arcs. So I know that this arc has to measure 140 degrees. So now, all the way around my circle is 360. I've already identified 280 degrees. So I'm left with 80 degrees, right? So this arc is 80 degrees, which then means my central angle is also 80 degrees. Next one says, find the circumference of a circle with a radius of 13 inches. Leave your answer in terms of pi. All right, so circumference, you can use 2 pi r here since I have a radius. So I have 2 times pi times 13, or 13 times 2 is 26 pi, and this would be in inches. And that is leaving your answer in terms of pi. The next one says, find the diameter of a circle whose circumference is 32 pi. So with a diameter, circumference is equal to pi times diameter. Okay, so my circumference is 32 pi. I want to solve for diameter. So now I can divide by pi, which will be a unit of 1 there. So then the diameter is 32 centimeters. Now, if you want to use that old formula of 2 pi r, we can do that as well, just we have to make sure we answer the question. So my circumference is 32 pi equals 2 times pi times the radius. So if I divide by 2 pi, right? If I divide by 2 pi, pi divided by pi is 1, 32 divided by 2 is 16 equals my radius. But keep in mind, I want my diameter, so I need to multiply that by 2, and that's how I get 32. Okay, number 21. Ms. Wilson purchased a welcome mat for her front door that is a semicircle. The straight edge of the mat is 38 inches. To the nearest inch, what's the perimeter of the mat? All right, so we have a semicircle here, and we know that the straight edge is 38 inches. Now notice that's also the diameter of that circle, right? So I need a half of the circumference, and then I need to add that straight edge. So my circumference, or my half of my circumference, right, is going to be 1/2 times pi times my diameter, which is 38. All right, so that's 19 pi. Now I still need to add in 38 inches. So this is what I want to type into my calculator. So I have 19 times pi and then I need to add 38 to that, and I get 97.690. It says round to the nearest inch, so that would be 98 inches. Number 22, circular metal rims are used to mount tires for cars. If a tire rim has a 22-inch diameter, what's its circumference? Round an answer to the nearest inch. So circumference equals pi times diameter. My diameter is 22 inches, so it's going to be 22 pi. It says round my answer to the nearest tenth of an inch. So I need to type this in. So I have 22 times pi gives me 69.115. So if I round to the nearest tenth, I'm going to have 69.1, and we are in inches. Number 3 says Mr. Haley's installing a guardrail around the edge of his circular swimming pool. The pool has a diameter of 23 feet. How many feet of railing would he need? All right, so we have a circular pool. I want to know the circumference. They give us diameter. So pi times diameter gives me, my diameter said it was 23 feet, so 23 pi feet. Round to the nearest foot, so 23 times pi gives me 72.25. So that means it would be 72 feet. All right, the next one, this is the one that I would draw to look like a kite. So if that arc is 120, that means my central angle is 120. Don't forget I have right angles here. So my x there is going to be 180 minus 120, which is 60 degrees. Number 25 is going to work the same way here. So I'm going to draw in my kite, my right angles. Now this time my major arc is 250, so I need to find that minor arc so I can get my central angle. So 360 minus 250 gives me 110, which means this central angle is 110 and this arc is 110. Now I know x and my 110 have to be supplementary, so 180 minus 110 gives me 70 degrees. Okay, so the next one here, there's lots of things happening over on the right. So I'm going to actually just look at my figure first and mark some things, and then I'm going to go from there. So I see over here at around H here, this radius is bisecting this chord, which means I have to have a right angle right here. I know I have a right angle there. Now I also notice over at chord AC, I have a perpendicular with a radius and that chord are perpendicular, which means that has to also be bisected. So I know that part has to be, AG here has to be 8. Now we can see the arcs at FE and ED. Those are both 41. Okay, so you have a, remember congruent chords have congruent arcs, right? So we have two congruent chords here. AC is congruent to FD, which means then all of FD is 82. So all of AC has to be 82, and it's going to be bisected just like it is over at FD. So I know this has to be 41, this has to be 41. I also noticed that GK here is 5. Okay, well, if AC is congruent to FD, remember that means that they're equidistant from the center of the circle. So that has to be 5. So let's see if we can answer some questions. So the measure of arc BC is 41. Segment AC. No, AG, that says AG. Segment AG is 8 units long. The measure of angle DHK, so DHK, I have it marked, it's a right angle, that's 90 degrees. Next one says if BE, so let's see, BE is, so B to E, here we go. If BE there, that whole thing I marked, is 160 degrees, what's the measure of CD? All right, so if we have 160, I've already identified 41 at BC and 41 at DE. So I really need to just subtract 82 from that, and I get 78 degrees. And then KH, we have identified as being 5 units long. All right, last problem. This is another problem that you can simplify by using a kite. Okay, I'm going to do this one both ways in terms of 1/2 of the major arc minus the minor arc, but I'm telling you the kite is way simpler. So if you use the formula 1/2 of the major arc, major arc minus the minor arc is equal to my angle, right? So my angle is 10x plus 11 equals 1/2 of my major arc, which is 39x plus 17 minus my minor arc. I had to subtract that entire arc, so I need to put that in parentheses. All right, so if I clean this up, first of all, I would multiply by 2 in order to clear out that fraction. So I'd end up with 20x plus 22 equals, so now I would have 39x plus 17. This then distribute that negative, becomes negative 18x minus 1. All right, so if I clean this up, so we have 20x plus 22 equals, and now I'm just going to combine my like terms here. So 39x minus 18x gives me 21x plus 16. I can subtract 20x from both sides, and I get an x. Subtract 16 from both sides, 16, and I get 6. So x equals 6. Okay, now this is where people goof up. They don't distribute that negative to both, and they end up with a positive one here, which then leads you astray. So now let me show you the fastest way I think to do it is I would draw in those radii, and remember that central arc or central angle is the same measure as that arc, and we know that the central angle and that exterior angle there are going to be supplementary. So that means that 18x plus 1 plus 10x plus 11 has to equal 180 degrees. Combine my like terms, I have 28x plus 12 equals 180 degrees. Subtract 12 from both sides, I have 28x equals 168. Divide both sides by 28, and I get x equals 6. All right, so just two different ways there to look at it.